Hi everyone. So today we'll be solving question number 32 from 2022 exam. So in this question, Raman line is observed at this ship at this wave number 300 centimeter minus 1 has intensity of Stokes line 4 times that of anti-Stokes line. So the temperature of the sample is, so basically one solid is given, and in that they have done laser Raman spectroscopy, and the Raman shift is observed at 300. So at that 300, at the intensity of Stokes line is 4 times of that anti-Stokes line. So we need to find out the temperature of that sample. So for that we should know the dependency of intensity on temperature for both Stokes line and anti-Stokes line. Before that, we will know this concept of Raman spectroscopy. What is this Raman spectroscopy? So basically, this phenomena is, suppose there is some wavelength, there is light of some particular wavelength lambda, and we have some material, and we have illuminated this material with this light of wavelength. Let's say the wavelength is x. So this crystal structure of material is having a lot of particle, atoms, molecules. So this light will interact with these these particles, and this particle will reflect this light. Suppose the wavelength x, after reflection we are getting the same wavelength, so it is a Rayleigh scattering. And if after reflection we are getting wavelength of higher value, that means we are getting Stokes lines. And if we are getting wavelength of shorter value, then it is anti-Stokes line. So in when Stokes line we will observe when the material absorbs some of the energy of this light and will move to excited state. That means particle is in the ground state, and this is illuminated with some radiation of wavelength x, and this particle has absorbed some energy of this light, and after absorbing the energy it is making the transition to the excited state. So there is some loss of energy from this parent this radiations, and there is a loss of energy. That means the wavelength will get increased, and when the material after interacting with the radiation will provide some of its energy, that means the energy has increased, so frequency has increased and wavelength is decreased, so we'll get anti-Stokes line. And when this material will provide energy to this radiation, when they are in the excited state and when they are making transition to the ground state, so that time they will provide their enough energy, their extra energy to this radiation. So this is Stokes and anti-Stokes line concept. Now coming back to our question. So in the question we know that IS, the dependency of Stokes line on the temperature, is given by 1 upon 1 minus e raised to the power minus h nu upon kBt, and for anti-Stokes it is 1 upon 1 e raised to the power h nu upon kt minus 1. Divide both of them, equation 1 and equation 2. So we get Is upon I anti-Stokes is equals to 1 upon 1 minus, I am taking h nu by kBt as x. So e raised to the power minus x, e raised to the power x minus 1. This will go to numerator. So this is Ex minus 1 upon 1 minus 1 upon Ex. So it is Ex minus 1, Ex minus 1, e raised to the power x minus 1, and this is e raised to the power x. So this will cancel. So intensity of Stokes upon intensity of anti-Stokes line is equals to e raised to the power x, taking log on both sides. So this is x, and we know x is value of x is h nu by kbt. This is h nu by kt. In the formula, we are given intensity of Stokes line is 4 times of intensity of anti-Stokes line. So this is log 4 h nu upon kt. We need to find out t. So this is h nu upon k log 4. Put the value of h. It is 6.626 10 raised to the power minus 34 joule second. This is nu is equals to c by lambda, and 1 upon lambda is wave number. So nu is equals to c nu bar, and c is 3 into 10 raised to the power 8, and nu bar is given to us 300 centimeter minus 1, and we are doing it in standard units. So convert the centimeter into meter minus 1, so it will be multiplied by 100. K is 1.38 into 10 raised to the power minus 23 joule per Kelvin. This is meter per second, and this is meter minus, and this is log 4. Now solve this. After solving it, we'll get, after multiplying all this, 59.634 into 10 raised to the power minus 34 plus 12 plus 23, 1.38 log 4, and t is equals to 59.634 into 10 upon 1.9. It will be 31.38 into 10 Kelvin. So this is 31.18. So it is 311.8 Kelvin. So the range will be 311 to 312. This is the answer. So the answer will be 311 to 312. Thank you.